All right, so now for this unit, what we're going to be looking at is what we call the trigonometric functions. Now, trig, for short, it's very, very useful. So we're going to be looking at those, in ratios is a fancy word for saying fraction, okay? So we're going to be looking at fractions. But before I look at our work from here, let me look here at the side. I'm going to talk about something here. Let's say we have a right triangle. So let me draw a right triangle. So I know right triangle has one of my angles, one of my corners, 90 degrees. And one of my other angles, let me introduce you guys to this Greek letter, theta. It looks like an O with a dash in between. Now, theta basically means measurement. So we like to use the Greek letter theta as a measurement of an angle. So having that said, having one of my angles to be 90 degrees and another angle called theta, I'm going to be able to give names to all three sides of a triangle. We know the big side. The big side, we know this as hypotenuse. Let me just write this, hypotenuse. We have known that. Remember when we talk about Pythagorean theorem, a squared plus b squared equals c squared, I said the big side was called hypotenuse. So that's something that we have known. Now the other two sides, they're going to be called opposite and adjacent. And the name opposite and adjacent depends on where theta is. In geometry, opposite means far away. Right? Kind of think when you're walking on the streets, you're walking on a sidewalk. What's the opposite side of the street? Well, far away. So opposite means far away. Adjacent means close to. So I see where theta is. This is the corner that is theta. Opposite is the side that is far away from that corner. So in this case, this side is what I'm going to call opposite. And then this other side, I'm going to call adjacent. Adjacent means close to, next to, right? In a classroom, sometimes people say, oh, talk to the student that is adjacent to you, right? The person that is close to you, the person that is next to you. So again, opposite means far away. Adjacent means close to. Now that we know the three names of the sides, we're gonna be able to create fractions. And we're actually gonna talk about 6 different fractions. The names that I'm gonna be looking at, one of them is called sine. Sine of theta. So I'm gonna write sine of theta. The other name we're gonna talk about is called cosine. Cosine of theta. Let me zoom out a little bit here. Tangent of theta. Tangent of theta. Let me also talk about cosecant. Cosecant of theta. Secant of theta. And cotangent. Okay, so those are the 6 ratios that I'm going to talk about. Now, on a calculator, we like to include keys for things. We're going to include keys that have these fractions. So for a calculator, later on, we're going to talk about how to use a calculator. For today, you should not be using one. But for later on, we're going to abbreviate each of the names to 3 letters only, especially something as big as cosecant. Right? Imagine if on a calculator, imagine the key of a calculator. If I wrote the whole name cosecant, that would be a lot to write. So the letters will be very, very small. So we're going to abbreviate this to 3 letters only. For sine, I'm going to abbreviate it to the first 3 letters. So let me just call S-I-N, theta. I'm still going to call it sine. I'm not going to read it as sin. It is still pronounced sine. Okay, sine of theta. And like I said, this is going to equal to a fraction. The same thing with cosine. I'll come to the fractions in a minute. Cosine, let me abbreviate it to the first 3 letters. So I'm going to go cosine of theta. Again, abbreviate it to only 3 letters. So I still call it cosine, not just cosine. Now tangent, as you guys can imagine, I'm going to abbreviate this to the first three letters. Tangent of theta, it is equal a fraction. So notice I'm drawing like line segments because I'm going to write a fraction for each of them. The same thing with cosecant. Now cosecant, I'm not going to abbreviate it to the first three letters because COS is already used for cosine. Instead, for cosecant, I'm going to write C as C. Cosecant of theta is equal to a fraction. Secant of theta, I'm going to abbreviate that as SEC. Right? I can use the first three letters. Cotangent, I can use the first three letters, COT. So cotangent of theta. So again, I'm going to be talking about 6 different fractions. Now we know that the three sides of a triangle have their own names. There's 3 names. So for sine, when I'm looking at sine, I'm going to look at opposite over hypotenuse. So if I'm asked, find the sine of theta, I'm going to see the 3 names of the triangles, and then I'm going to do opposite over hypotenuse. For cosine, I'm going to do adjacent over hypotenuse. In tangent, I'm going to use opposite over adjacent. Okay. So we see the sine of theta is going to be opposite over hypotenuse. Cosine of theta is going to be adjacent over hypotenuse. Tangent of theta is going to be opposite over adjacent. As a matter of fact, let me give you guys an acronym. I don't like to use acronyms that much, but let me give you guys an acronym that was going to help us out. I'm going to use SO, CA, TOA. Sometimes when you guys go to math classrooms, you guys see SOHCAHTOA somewhere on a corner. And what we mean, I'm going to read letter by letter, but not going to just read the letter. I'm going to say what it represents. I'm going to abbreviated words. So the S stands for sine. So here on the phrase sine, opposite over hypotenuse. Notice how opposite comes first. So it tells me what goes on top, over, and then the last letter represents what's at the bottom. So I have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. So if you guys are ever working on trigonometric ratios and you guys need to remember the fraction, just remember SOHCAHTOA. So you guys should be able to write sine, cosine, and tangent. Now let me talk about the other 3. There's cosecant. Now let me start with cotangent. Let me start here at the bottom. COT. Okay, cotangent, COT. I see tangent is TAN. Give or take, it looks like cotangent, looks like tangent backwards. So cotangent is going to be the reciprocal of tangent. Okay, let me say that again. Cotangent is going to be the reciprocal of tangent. I remember back in algebra, we talk about reciprocal. That's when you flip a fraction. So cotangent of theta is going to be adjacent over opposite. See how tangent and cotangent are reciprocal of each other. Same thing with secant. If you read SEC, kind of looks like COS backwards. Secant of theta is going to be the reciprocal of cosine. So I'm going to say for secant, I'm going to do hypotenuse over adjacent. And then cosecant is going to be the reciprocal of sine. So I'm going to write that as hypotenuse over opposite. So remember, SOHCAHTOA help me remember sine, cosine, tangent. Remember sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. I know cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. This chart, this table, is going to help us with our ratio. Remember, ratio again is the fancy word of saying fraction. So from now on our notes, when I say according to our table, this is the table that I'm talking about. So again, if I say according to our table, just you should have this on your notes. Okay. Now let me take a look at here. Find the value of the trig function indicated. Okay. So I see cosecant of theta. What I'm going to do first, let me label the three sides. Remember, as in hypotenuse, adjacent, and opposite. So I'm gonna, I see the 90-degree angle, and always opposite from the 90-degree angle, always farthest away from the 90-degree angle, we have the biggest side, which is the hypotenuse. I'm just gonna use H for hypotenuse. I see where my theta is. Theta is on this corner. Okay, farthest away from theta, so farthest away from theta, that's what we call the opposite. I'm just gonna call this O for opposite. Next to theta, this is what we call adjacent. I'm going to use A for adjacent. So I label the three sides. I know cosecant. I even go back to my notes and I'm like, cosecant is hypotenuse over opposite. Hypotenuse over opposite. So I'm just going to go 24 over 12. And then simplify your fraction if possible. Some of your fractions do finish as a fraction. Some of your fractions simplify to a whole number. In this case, 24 over 12. I can say, well, let me divide each by 12. So that gives me 2 over 1. However, any fraction that is over 1, it is not a fraction anymore. It simplifies to a whole number. So in this case, my answer will be 2. Again, some of your answers will still be fractions. Some of your fractions will just be a whole number. Some of your fractions will have radicals as well. We talked about radicals before. Remember, I used the phrase rationalize the denominator. I used that in the previous notes. If we have radicals, it is okay to have a radical on top of the fraction, but it is not okay to have a radical at the bottom of the fraction. So we'll see those in a minute. For sure, we'll see some of those. Now, let's take a look at question number 2. Let me start by labeling my sides. Remember, hypotenuse, opposite, adjacent. So first, I find the 90-degree angle. And I'm like, all right, farthest away, that's the hypotenuse, the biggest side. Let me find my theta. Theta's right here, farthest away. So opposite from theta is my opposite. And right next to theta, we call that adjacent. Now, cosine, according to our table, remember I said I was going to just say according to our table, cosine is adjacent over hypotenuse. So I'm just going to go 23 over 23 radical 2. Okay, to begin with, my 23's cancel out. So it looks like I just have a radical 2 at the bottom. Now, the top of a fraction, we cannot leave it alone. We cannot leave the top of a fraction alone. So I'm just going to put a 1 on top. Okay. Okay, I see I still have a radical. And radicals are okay. However, I cannot have a radical at the bottom of the fraction. And then we talked about this before. The radical at the bottom, if it's a perfect square, nice. It stops being a fraction. You know, make it a perfect square. It stops being a fraction. Now, what if it is not a perfect square? Like it is our case. What I'm going to do, let me multiply top and bottom by radical 2. Notice I did times radical 2 over radical 2. When you have a fraction, when you multiply by a fraction and the top and the bottom are the same thing, you're basically multiplying by 1. So you're not changing the value of anything. However, look what's going to happen. Here on the top, 1 times radical 2, we can write that as 1 radical 2 over, because remember, I have to multiply whole numbers with whole numbers, radicals with radicals. I don't mix them. So I do have a 1 as a whole number, and I have a radical 2 as a radical. So first I could do that. However, so there's a however. When there's a 1 in front of the radical, sometimes we choose not to write it. So let me not write this. So I'm just going to call it radical 2. Now at the bottom, when I multiply my radicals, that becomes radical 4, right? Because 2 times 2 is 4, right? Radical 2 times radical 2 is radical 4. However, I was able to multiply them because they were radicals. However, my radical at the bottom stops being a radical. It becomes a whole number because the square root of 4 is that's a perfect square. The square root of 4 is actually 2. So it seems like I have radical 2 over 2. Now, those numbers, the 2's, look very similar, but they're not quite the same thing. Okay, the 2 on the top is radical 2. The 2 at the bottom is a whole number 2, so it is different. So I'm not going to cancel my 2's. My radical is as simple as I can. When I'm looking at the whole numbers, nothing I can do. So that is my answer, radical 2 over 2. Now, how am I going to type this? Remember, radicals, we write that as RAD, open parentheses, 2, and close parentheses. Don't forget to close parentheses. I saw some of your assignments from last week. Some of you guys got a few answers wrong because you guys were not closing the parentheses. So make sure you guys remember that. Some of you guys fixed them, so that's good. So I see radical 2. I'm going to write that as RAD, open parentheses, 2, close parentheses. And then I'm going to do a backslash. With the backslash, basically, I say to have a fraction. Everything before the backslash is what I have on top of the fraction. In this case, radical 2. Everything that I have after the backslash is what I have at the bottom of the fraction. So 2. And that is my answer. Radical 2 over 2. Again, my radical 2, you guys see it before the backslash. My 2, do you guys see it after the backslash? So some of your answers will be fractions. I called it ratios at the beginning, which I said ratio basically means fraction. Okay, so now looking at question number 3, sine of theta. I'm asking you for the sine of theta and I gave you a triangle. Let me label the 3 sides. I look for the 90-degree angle. Farthest away from the 90-degree angle, we call that hypotenuse. I look for theta. Theta is right here. Farthest away from theta, we call that opposite. So then this other side is going to be called adjacent. Okay, sine of theta. According to our table, remember you should have the table in your notes. Sine of theta is opposite over hypotenuse. So I'm just going to go 5 over 5 radical 2. Okay, cool thing, my 5's cancel out, so that makes it easy. I have a radical 2 at the bottom, nothing on top. I'm going to have a 1. It looks a very, very similar question. Again, if you guys forgot already, I'm going to multiply top and bottom by radical 2. So on the top, 1 times radical 2, I'm just going to call it radical 2. At the bottom, radical 2 times radical 2 is radical 4, but the square root of 4 becomes a whole number. So my answer here it is radical 2 over 2. And the way I type that is radical 2, so RAD, and then 2 inside parentheses, backslash, because I have a fraction, 2. So radical 2 over 2. All right, let's take a look at our last question here. Tangent of theta. Okay, first, let me label the 3 sides. I look for the 90-degree angle. Farthest away from 90-degree angle, that's what I call hypotenuse. I look for theta. Here it is, this corner. Farthest away from theta, that's what I called opposite. And then this other side is going to be called adjacent. Now, according to our table, tangent, because I'm asking for tangent of theta, according to our table, tangent is opposite over adjacent, O over A. So I'm going to go 9 over 6. Some of you might be like, oh, good, it is not the one with the radical. Sometimes we have it, sometimes we don't. However, simplify your fraction. 9 over 6, we can do better. Right? If this was a homework assignment and I type in 9 over 6, it will mark it wrong because it is not simplified. So I'm thinking 9 and 6, I should be able to divide it by something. What number are 9 and 6 divisible by? Okay. I have to divide 9 and 6 by something. Don't divide it by 1 because dividing by 1 does nothing. Okay, let me divide it by 3. So I'm gonna go 9 divided by 3, 6 divided by 3. I know 9 divided by 3 is 3. 6 divided by 3 is 2. So, okay, I made my numbers smaller. Then I ask myself, can I simplify even more? No. Okay, now in this case, we cannot. So that's my answer, 3 over 2. I still have a fraction. My answer will be 3 backslash 2, right? 3 over 2. Let me zoom out. That way you guys can see what we did today.